the ArchCode paper dropped this week, and
Yes.
we were so relieved.
Yes.
Because we felt like we've been building towards this more holistic innovation from requirements towards software development, and we felt a little bit alone. We have the conviction because we've seen the results ourselves, but seeing a paper published that is approaching it in a similar way,
Yes.
that certainly has some downfalls. We'll talk about that, but was a nice moment. So ArchCode drops this week. Really smart folks wrote the paper. So give us the once over on what these folks published.
Sure. So I think it's a brilliant idea. It's basically, how do you get an LLM to give you code that matches your use case and meets all of your requirements? And not obviously, the answer is like, be more specific.
Yeah.
The way the industry has solved for, getting better high quality outputs from LLMs has always been prompt engineering.
Yeah.
And my view of this paper is ArchCode is a framework.
Yeah.
But what they really are solving for is prompt engineering for code generation.
Yeah.
And the way they're doing it is, instead of giving an LLM a goal or a use case, like, hey, can you generate code that does this? In which case, the LLM will take that, and then internally it's just a computer that's using its memory, which is massive.
Yeah.
It's trained on terabytes of data. It's going to look that up and make an intelligent response. It's going to assimilate all that information and give you an intelligent response as to something, code that solves your requirement. But as it turns out, that the ArchCode paper authors discovered, if you are more specific, and let's say you have a requirement to write code to do something, and then you break that down into the functional requirements, which is essentially the business logic of what you want the code to do, and the non-functional requirements, which could be the time complexity, the cyclomatic complexity from a maintenance standpoint, the error handling that you would like it to be done. So those are some non-functional requirements. If you do that, and then you give that to the LLM, it's much more effective, because now it's not just solving against your use case, it's also solving against these requirements where you can effectively measure its performance, right? Because now you have metrics.
Yeah.
And you could also maybe use another LLM as a judge to be, an evaluator of this performance and introduce a lot of dynamicness in this process.
So it's taking a bit of a macro view on what you're actually trying to achieve, as opposed to saying like, hey, Copilot, like I need to like organize this list, create a Python function. Like very little context, right? Like the focus of Arch is saying, let's use very deliberate in context learning for the LLM in a very specific way around a very specific type of really product requirements document. And in doing so, they've seen much improved results. And so we are excited because other folks are thinking about this, but let's talk about like where we don't think ArchCode has gone far enough, or like what the next areas to sort of like push the boundary are on this.
Yeah, well, if you think of this in isolation, you're talking to an LLM, you're giving it some code, and you're giving it a requirement, it's giving you some code. It makes sense. But if you think about it practically in, let's say, an application that you're building in a production environment, I think it's almost impossible that you will be working with a single module.
Yeah.
You're going to be working with a bunch of modules, a bunch of systems, each of which will have their own requirements, and each of which are operating codependently, independently, a mixture of that, right? And when you have complexities at those levels, simple requirements don't help. You need to have a pattern for interaction.
Yeah.
You need to have a pattern for operation.
Yeah.
And that's where design comes in.
Yeah.
And
not visual design. Well, it could be technical design.
Technical design.
Yeah.
That defines all of these patterns, that defines schemas, that defines the inputs, outputs, and processes, and everything around that.
Yeah.
And that's where things start getting a lot more challenging.
Yeah.
Because you can't break everything down into functional and non-functional requirements. There's a lot more that you need to address. And that is, I think, a good future direction that this could take, and that we've been addressing from the ground up. Because if you think of the software development lifecycle, it starts from what you mentioned, the product requirements document, where speak to client, capture their requirements. You then translate that into a software requirements document, or an SRD, which is more technical. And then it boils down to the tools you would use to actually solve for that, and the metrics that you would use to evaluate against your success. And then you go to the next step, which is a design, before you actually start writing the code. So and the design is what defines the interaction patterns and all the different players and the schemas. And as it goes in the industry, a good software engineer will never be writing the code first. They'll always be going through this process. And coincidentally, for LLMs, the more specific you are, the better they perform. So what we see happening in this space is, as the industry realizes that and develops more methods to test that effectively, we will see a lot more efforts being put into this space to just get better code generation from LLMs.
It's sort of interesting because there's this view that LLMs are going to be replacing really junior engineers, right? It's like, okay, like the work a junior engineer might be doing is, hey, go write functions for XYZ and sort of like send them off in isolation. They'll figure it out, they'll learn, they'll go better. They might do a small portion that it can be contributed. But it also might just be that like we are treating them like junior engineers, right? Like, and not to say that like we can just treat them like senior engineers and say build an app. Like that's not sufficient, but like that's also not how anyone would work with a team of engineers. They would be able to go from product to SRD to technical requirements to then hand it off to the engineering team, right?
Yes.
And so that process that we use in an enterprise, like may well be the process that we need to operate with these LLMs if we want them to elevate their game.
Yes, absolutely. Because if you think about it, there are some apps today, like we see a lot of posts on LinkedIn, on Reddit, and many on social media in general, where people get excited when an LLM is able to generate a game for them. And it happens to be, for them, a dynamic prompt. Like I went to the LLM, I said, hey, can you generate Pac-Man for me? But instead have the small variation where it does XYZ. And then the LLM spits out code that is Pac-Man. And in that particular case, the LLM is doing both the front end and the back end of the game. So it is doing multiple things.
Yeah.
But the point that everyone misses in those cases is there's a lot of open source code out there.
Yeah.
There's terabytes of code.
Yeah.
And the likelihood that a Pac-Man game exists is super, super high.
Right.
In that database.
So at this point, a retrieval game.
Yes.
They're almost retrieving in the entirety of the game.
Yes.
Yeah.
So for an LLM to generate like a common use case or a common solution like that is very trivial. And that is why they're great at it. Like I think the latest models do really well at generating games and that kind of simple stuff. The challenge happens when you work with data. And data that is non-standard, data that is not likely to be in open source or well documented, and that puts together multiple different modules and solutions that you have to solve for independently. And that's the first level of challenge. The second challenge is how do you scale that and make that production grade?
Yeah.
Because enterprises are not in the habit of releasing their code, their proprietary code to open source, right? And that's not going to happen in the near future.
Yeah.
So how do you solve for that? Well, you help the model along, like the ArchCode authors did.
Yeah.
But you need to go beyond just the requirements and into design, and that's where the science separates from the art.
Yeah. Which I think again, like the great builders know that this practice is as much art as it is science. So like we have to get there, and so like we've seen a few folks. We're excited because we've seen the prevailing opinion be like, let's just throw more code at these LLMs and train them on it. And like that actually might help, right? Like, but like that is both extremely expensive and limited to a very small number of players that are going to approach that, which leaves the rest of the world, right, to say, oh, we'll just wait for, Microsoft to train another code specific model, which is like the biggest areas to actually push innovation, we believe, are all the things that are surrounding what we're doing with the model. And like the big players are going to go do that and we should benefit off of that.
Yes.
But it's not going to get us there by itself. And so from your perspective, like how much room do we have on the gobs of training code specific models versus the scaffolding, the approach, the surrounding processes, the structure that we provide to get software out the door?
I'm a strong proponent of the latter,
yeah,
which is grooming the LLM's processes and outputs, then on training code-specific models. And the reason for that is code-specific models is something that was hot some time ago, but it's no longer the case. And the reason for that is, you had Code Llama, you had other code-specific models, but what happened was the baseline models that are trained on a bunch of text and code got so much better and so much good at generating code
Yeah.
that the code specialized models just got out of fashion.
Yeah.
And there's a reason for that. The thing is, code is produced by humans.
Yeah.
Most likely is English. Even though there may be some syntactical rules, all of those rules are well defined in documents and well documented extensively,
Yeah.
right? And well exemplified based on how much code these LLMs are seeing, because they're seeing terabytes, right? So with that, the game changes from feeding the LLM more code, which, yes, as you said, as you have more parameters, maybe we'll reach a breaking point where at some point it's no longer useful to feed the LLM more code, and I'm pretty sure there are tests and experiments and research being done in this direction.
Yeah, to figure out where that limit is, right?
Exactly,
Yeah,
to figure out where the efficiency limit is.
Yeah.
But what really matters is, we will keep getting better models. There's no doubt about that.
Yeah.
They'll be better either in terms of their, if it's a transform architecture, they'll be better in terms of their memory retention.
Yeah.
They'll be better in terms of their inference speed. But it's like you have this tool that is incredibly powerful, but you need to know how to be able to use that tool, and you need to set it in the right environment with the right conditions and enable it to perform and to do what you want to do. And that's how it's interesting, because that's how computers really are.
Yeah.
You need to, the difference between working with a computer and a human is you need to be very specific about what you want with the computer. Now, the difference with an LLM in the middle is that you have an LLM that can fill in the gaps for you,
Yep.
right? Which you don't have in the computer, in a plain programming language. So if you make a small mistake in the programming language, like in C++, if
You're
you miss
done. Yeah.
a semicolon, code
Forget about
crashes.
it. Yeah.
But the LLM might be able to fill in that semicolon with
Yeah.
you, for you, if you miss that, and give you maybe code that compiles. But then you're really pushing the limits, because that's an inefficiency there that the LLM is covering for you. It will be able to do better if you are more specific, and if you define your requirements, your designs more carefully, put a lot more thought into that. And that, like we said earlier, is prompt engineering at the heart of it.
Yeah.
But the benefits is, when you are, for example, if you ask an LLM, hey, give me code that does this, let's say it finds a factorial of a number, and then you give it a second prompt that says, I'm doing this in a cloud-based environment, give me secure code that solves for this use case. It's going to access a different part in its learned parameters to generate the ladder code. And that's what you want to do. You want it to be able to access the right parts, which is high quality code, which is specific to your use case. And that would enable the LLM to give you exactly what you want.
Yeah, but I mean, yes, we want to find the right latent space within the model, sure. But I'm also hearing from you that that single prompt as a single prompt is marginally improved versus the full picture of what you are trying to achieve and communicating that. So what I'm hearing is, like, when you're saying be more precise, you're not saying be more precise in this 2-sentence thing. You're saying provide deep context across the entire product that you're trying to build and the relationships between the items within that product. Is that right?
Yeah, that is on the right track. The thing is, you need to be mindful about the context window. Different LLMs have different levels of accuracy within the context window. So an LLM might specify that, hey, we're able to work with 16,000 tokens or 4,000 tokens or 8,000 tokens. But if you actually run tests on the quality of outputs that you get relative to the size of your input, things change drastically as you tweak the size of the input. Mm-hmm. So even though an LLM could work with 8,000 tokens, it may not do its best job on completing all of the parameters that you have in the task. Mm-hmm. And there are multiple solutions for that. So we now have, agentic workflows where you have different LLMs specializing on different tasks and completing specific parts of the problem. So if you think of it like an assembly line, where someone's putting together the wheels, someone's assembling the interior, someone's painting the body. If you use that kind of specialization with LLMs, it's more effective because you're grooming the LLM's memory or the parameters or the latent space that it's accessing to access specific parts. And there's a specialization in that sense. And you can exploit that specialization by choosing different kinds of models. You may learn in your experiments that, let's say, body painting, and think of it in a software context.
Yeah.
is a job that is not as complicated as maybe interior setup. So you could use like a smaller model for that specific task, and you could use and that way you could save on cost.
Yeah.
And then you could save your best and largest models for the more complicated tasks. And that way now you have this workflow, you have this process that is incredibly specialized, that is efficient, and that is precisely giving you what you asked for.
And it's all the more exciting when it's all the things surrounding the transformer as a standalone, because we can sort of pull out different transformers, we can fine tune different transformers. And then when we see papers like Arch come out, that, okay, there actually is a multi-step process to providing information, to providing guidance. Like, it provides more credence, more credibility to the multi-agent architecture. I feel like a lot of folks have been very excited in the last 12 months about multi-agent when it came out. Some of the frameworks came out, and I think there has yet to be a lot of meaningful products materialized from that. So talk to us about, I mean, you're in this every single day, right? Like, talk to us about what the state of multi-agent is today.
When it comes to multi-agent, the thing that we need to keep in mind is that the LLM is a probabilistic computer.
Yeah.
And depending on the quality of the model, the size of the parameters, the specific use case that you're asking for, how common it is, how well defined it is, and what your goals are, there is a decent chance that the LLM will solve for and give you exactly what you're asking for. Typically, that chance with code generation tasks is about 65% with an average everything, average prompt, average model, all of that. But when you put multiple models together, that's a compounding probability. So what I mean by that
error.
is, yes,
Yeah.
of error, right?
Yeah.
So when I give a prompt to a model, depending on the quality of my prompt, if I run that prompt 5 times, it is quite likely that I may see 5 different responses. And the differences would be not just in the code, but also in the model's understanding of what it was trying to do when you gave it that prompt. It's less likely that you will see, hopefully, it's less likely that you will see completely different responses, but there will be differences.
Yeah.
And in computing, like, a single line difference can make or break a code, right? It could cause your code to crash. It could not solve for your use case, give you junk output. And when you think of an agentic system, you can't have a human supervise every single flow and interaction, because that would defeat the purpose, right? So if you aggregate and compound this chance of error, which is 35%, and you multiply that, and you would multiply the success probability of 65%, right? For every subsequent agent that you add, the level of quality drops significantly.
Yeah.
Like, we've seen this in earlier papers where they calculated like a $4 cost to run a single prompt on a multi-agent system that was, I think, 5 nodes deep. And that $4 is significant. We do believe that cost will go down, but the problem there was not the cost itself, but the fact that it took several runs to get something right. And if I have a problem to solve and it takes me 10 to 12 runs to get something right, and I need to incur the cost of actually verifying if the model's got it right, then that system is not really useful for me, because I can never get the N correct. I only can guess that maybe, let's try it 10 times and then let's see where that goes. But that's like monkeys throwing things at a wall hoping that it will stick.
Yeah.
So that's the challenge that the computer scientists in the space are actually solving for at the moment.
Yeah. And what's the thinking on how to approach this, where we might actually see this chain of thought probability not be true?
I think zero shot is a promising way to do this. Also, you can do one shot cases where you show the LLM give the LLM some examples and set grounding on what is expected of that model, and have multiple LLM as a judge. We've talked about that before, where an LLM produces some output and that's evaluated by another LLM against some metrics, and that gives you a sense of quality
Mm-hmm.
as to if the LLM is on the right track. So if your first LLM did not give you a high enough quality output, you don't have to feed that response to the second agent,
Mm-hmm.
because there's a high likelihood that a task will fail.
Right.
So there are techniques like that, but in general, what I am more bullish on is if you're able to get a good enough response at the first time, and that could mean having a strict schema for what your LLM is generating. It could
Yeah.
mean grounding your LLM in a graph-based data structure, which is very much more precise when it does retrieval against some database, right? It could mean just running multiple tests to ensure that the variability between outputs is not very significant and they're not dependent on that multi-shot prompting.
Yeah.
So I do think it's a solvable problem.
Yeah.
Not for every single use case.
Right.
But we've been able to work around this limitation for quite a bit.
Yeah, we've certainly been able to get much more reliable than
Yes.
what we see on the open market, which is exciting because even the ability, there's quite possibly no more productive task worth pursuing than achieving this outcome, right? Because we go from this co-pilot type relationship to where the human's the driver and the co-pilot's the assistant, to really allowing the AI to drive the first pass of everything in a way that's super successful, and the human sort of being able to come in and be the assistant. And so you're shifting workload from the human being like having 70% of the workload, and now the human having maybe 30%, 20%, 10% of the workload.
Yes.
Which all comes back to output, right? Like what can they fundamentally build?
Yes. I think what you're describing, put differently, is that if you think about Copilot, and there are multiple Copilots out there. There's the Microsoft Office Copilot, there's the Windows Copilot, there's the GitHub Copilot, and they're all solving for different things, but they're each in their places quite broad.
Yeah.
And they're focused on the ability to be a tool for a specific user in a specific context, which is great. Like as a developer, having a Copilot that can complete tasks for me and make me more productive, it all makes sense.
Yeah.
But what we're solving for specifically is how do you take a requirement, and that requirement is a product requirement, and there are multiple supplementary, complementary requirements that may or may not overlap with it. And how do you take that set of requirements all the way further down the software development lifecycle to a product, to a tested, deployed, production scale product?
Yeah.
And how do you fill in all the steps in between and create purpose-built agents that solve for specific use cases along that line?
Yeah.
You still need humans. We're not at the point where, as you said earlier, LLMs can replace the humans, but we're certainly at a point where LLMs can make the humans far more productive.
Yeah.
And I think
far more productive than what we're seeing today. Then
absolutely. And 40% with a Copilot is great.
Yeah.
All our developers use Copilots.
Yeah.
Absolutely. But you're leaving a lot of opportunity on the table.
Yeah.
We've seen that you can go all the way up to 80 or 90% of automation for getting things done for specific use cases.
Yeah.
And that is a deal breaker. It's groundbreaking in a sense, because now instead of having to spend, like, let's say, months developing something, you could spend weeks.
Yeah.
But the challenge there is how do you optimize the process such that you don't have to rework any of the things that the LLMs give you.
Yeah.
And that's the challenge that we're working on day and night to perfect the system.
Yeah. Well, thanks to the authors of ArchCode, we are pumped you guys are out there, and we're kindred spirits with you. So good talk, man.